Are we alone in the universe? It's a question we've been asking ourselves for, well, forever. But lately, scientists have moved past just wondering. They're actively listening for an answer, on a scale that's almost impossible to imagine. Today, we're diving into one of the biggest searches for cosmic company ever, and the deep, profound silence that it found.
Just get a load of that number. Researchers from places like the SETI Institute didn't just scan a few stars in our cosmic neighborhood. Nope, they pointed their telescopes at 2,880 different galaxies. They were listening for what they call technosignatures, the telltale signs of technology. This wasn't a search for microbes. This was a hunt for galactic empires.
And the scientific community was genuinely hopeful. As Dr. Chenoa Tremblay put it, this whole project was a massive leap forward. They were using this incredibly powerful radio telescope in Australia, the Murchison Wide Field Array, which let them scan huge patches of the sky all at once. Everything was lined up for what could have been the single greatest discovery in all of human history. So after they collected over 17 hours of solid data from all those thousands of galaxies, and after sifting through all that cosmic static for any little blip that stood out, there was just silence. Not one single definite sign of technology. And this result, or I guess this non-result, is exactly what makes this whole story so compelling. Why, when we look out at a universe so vast, is it so quiet? Okay, so to really understand what this silence means, we first need to get a handle on the sheer scale of what these scientists were looking for. I mean, for a signal to be detectable across galaxies, it would have to be unbelievably powerful. We're talking about a civilization that is way, way beyond anything we can currently do. To wrap their heads around this kind of power, scientists use this really fascinating idea called the Kardashev scale. It's a clever way to categorize these hypothetical civilizations, not by their culture or biology, but by something universal, energy. It basically just asks, how much power can you control? And get this, we, humanity, we aren't even on the scale yet. We're what you'd call a Type 0 civilization. A Type 1 can control all the energy of its home planet. But this search, it was looking for the real heavy hitters. Type 2 civilizations that can harness all the energy of their star, maybe with something like a giant Dyson sphere. And then there's Type 3, a civilization that commands the power of its entire galaxy. Just imagine being able to dim and brighten spiral arms like a light switch. The energy they'd be throwing off would be detectable millions of light years away. And that's exactly why finding nothing is so significant. When you're looking for civilizations that powerful, silence isn't just an empty result. It's a really profound clue that deepens a cosmic mystery that has been puzzling us for decades. And this gets us right to the heart of it all. It's called the Fermi paradox. The universe is unbelievably old and ridiculously big, filled with trillions upon trillions of planets. Statistically speaking, intelligent life should have popped up all over the place, and at least some of them should have gotten advanced enough to send out signals or travel between stars. But when we actually look and listen, nothing. The universe just seems completely empty. This really profound silence has pushed scientists to think about some truly mind-bending and, let's be honest, pretty unsettling possibilities. And these aren't just ideas from science fiction. They're serious hypotheses trying to explain why the cosmos is so quiet. Let's take a look at 3 of the biggest ones. First up is the Great Filter. The idea here is that on the long, winding road from simple chemistry to a galaxy-spanning empire, there's at least one step that's almost impossible to get past. It's like a cosmic hurdle that trips up pretty much all life before it can really get going. This here shows you the incredible billion-year-long obstacle course that life has to get through. And the absolutely terrifying question is, where on this list is the filter? Is it in our past, meaning we're one of the lucky few who somehow made it through? Or is the Great Filter still ahead of us, some future challenge that almost no one survives? It actually leads to a weird conclusion. Finding simple life on Mars would be terrible news, because it would mean the early steps are easy, making a future filter for us much more likely. Okay, then there's this one, the dark forest hypothesis. It's a chilling idea. Imagine the universe as a dark forest at night. Every civilization is a silent hunter, hiding behind a tree. You can't know if another hunter you see is friendly or hostile. So the safest thing to do isn't to shout hello, it's to stay absolutely silent or to eliminate any other hunter you see before they see you. In this scenario, the sky isn't empty. It's just quiet because everyone is hiding for their lives. All right, a less terrifying, Though maybe a lonelier idea is the firstborn hypothesis. This theory suggests there's no paradox. The conditions in the universe might have only recently become right for intelligent life to develop, and we just happen to be one of the first to the party. We're not late, we're just incredibly, incredibly early. So these are all fascinating, if kind of spooky, theories. But for years, that's all they've been, just theories. Because our ability to actually listen has been seriously held back by our own tech. But all of that is starting to change, big time. So let me put this in perspective for you. With the old systems, scientists were constantly falling behind. Think about it. They were trying to drink from a fire hose of cosmic data with a tiny straw. For every 16 seconds of data they captured, it took them almost a full minute to process it. We were basically drowning in information, and who knows what discoveries were lost in that backlog. But now you bring in the new AI. It doesn't just keep up, it's so fast, it's practically waiting for the data to arrive. It can process all that information from the telescope more than 160 times faster than it comes in. This is a game changer. For the very first time, we're not just recording the universe, we can analyze every single bit of it instantly. Nothing gets missed. And it's not just about speed. As Dr. Andrew Simeon from Breakthrough Listen points out, this AI is so smart, it can learn to spot patterns that a human researcher might completely miss. I mean, what if an advanced civilization uses a type of signal we can't even comprehend? This AI could be the key to finding something truly alien in that sea of noise. And this brings us to a really critical question. With these powerful new AI tools, our chances of actually detecting something are better than ever. So, if we finally succeed, if we get that one confirmed signal from an extraterrestrial intelligence, what do we do next? Is there a plan? Turns out, yes, there is. The International Academy of Astronautics has this set of principles. It's not a law, but it's the protocol that most scientists in the field have agreed to follow. Step 1, verify the signal with other scientists around the world. Step 2, tell everybody, including the UN. But the most important rule is the third one. Do not reply. At least not without a global conversation first. Because if the dark force theory is even a little bit true, shouting back into the unknown could be a very, very bad idea. And that brings us right back to where we started. Our new AI might finally let us hear a whisper from the cosmos, but it also forces us to face those unsettling theories head-on. If the universe really is a dark forest, making a noise could be the last thing humanity ever does. So the question becomes, if we finally hear that voice in the dark, what should we do? Should we answer, or should we just stay quiet and listen?